Hey, algebra students. In this lesson, we're going to be talking about solving equations that are a little bit more complicated. Now, there are some general things you can remember when solving any equation. First of all, solving equations, we use order of operations in a sort of different way. But the key thing is we're using something called inverse operations. Inverse operations are operations that undo current operations. Okay, so if I'm adding 6 to something, the inverse operation is to subtract 6. Subtraction is the inverse of addition. Uh, Division is the inverse of multiplication, and then vice versa, right? Addition is the inverse of subtraction, and multiplication is the inverse of division. So, whatever operations are being done, we can undo them by using inverse operations. We do that to both sides of an equation. That's what made equations unique, is that when we have an equal sign, we can do the same thing to both sides without changing the value. And then order of operations is important because when we solve equations, we use the reverse order of operations to solve. So instead of starting with parentheses and then exponents, we end with exponents and then parentheses. When we're solving equations, we do. And we start with addition, subtraction, and then multiplication, division, and we go from there. So that's what we're going to be doing in this lesson. Is we're going to practice solving now what are going to be more difficult equations. They're going to take several steps to solve. A and B are just a setup for this lesson. So we're not actually going to solve an equation in A and B. We're just going to say what step we're going to do first. And A and B sort of go together because they're going to show us the difference between an expression. Okay, look at letter A. Notice in 9y plus 6 here, there's no equal sign. That's just an expression. But now in 9y plus 6 equals 24, this is an equation. So what's the difference between an expression and an equation? Well, in letter A, which step would you use first to evaluate if I know that y equals 2? Well, okay, the first thing I would do, according to order of operations, I have to do, let's see, parentheses, but there's no parentheses or other grouping symbols. Then exponents, there's no exponents. The next thing is multiplication, division. There is a multiplication. So we would do the multiplication of 9 times 2. Okay, so letter A is 9 times 2. Multiplication. Letter B, if I'm solving an equation, instead of starting with the beginning of order of operations, we're going to start with the end of order of operations. We're going to do reverse order. Which step would you use first when solving 9y plus 6 equals 24? Well, we're going to do the lowliest operation, subtraction. Subtract 6 from both sides. Hey, important thing to note right now as we're getting going here. I just want to point out that when we solve equations, our goal is to get a variable on a side all by itself. How are we going to get y by itself? Well, the first thing we're going to do is subtract 6 from both sides. That gets the y term by itself, 9y. And then if we just divide both sides by 9, we would have y all by itself. Okay, let's move on to letter C. We're just going to keep going down the page here. 8w minus 4 equals 28. Now, when we're solving equations, the best thing to do is to just write out the entire equation in your work, starting by just copying exactly as it appears wherever you're getting it from. The next thing we're going to do is inverse order of operations. So in this case, I'm going to, reverse order of operations with inverse operations. I said those two together. Maybe that's not the worst thing. Hey, the first thing I need to do is subtraction and addition to start getting 8w by itself. Do I have anything being subtracted from the 8w term? Yes, minus 4. So I'm going to add 4 to both sides of this. Okay? When I add 4 to both sides, I get 8w equals 32. Next, I'm going to do the next inverse operation, which is dividing both sides of this by 8. Okay? When I divide both sides by 8, now w is all by itself, and I have w equals 8. And that is how you solve these sorts of problems. Notice that I had to do 2 steps to solve that. I had a subtraction step, and then I had a division step. And we're going to have to pay attention to that when we solve equations. Let's do letter D. Letter D, now notice that x is on the other side of the equal sign compared to the previous problem. Okay, so one of the things that I like to do, this is an optional step, I guess, is get x on the left side of the equation. I don't always do this in every problem. You're going to notice that I do this sometimes selectively when I think it's going to make things easier. But it's usually easier just to keep x on the left side of the equation. So this gives me 2x minus 10 equals, and then I canceled out the x over here, so equals 12. Next thing I'm going to do now is add 10 to both sides of the equation. Plus 10 on this side, and then plus 10 on this side. That's going to give me 2x equals 22. Next, we divide both sides of this equation by 2 using reverse order of operations. I started with an addition to get rid of subtraction. Now I'm doing division to get rid of multiplication. That's going to get x by itself. X equals 11. And one of the great things about these types of problems is I go back in and check by actually just doing the multiplication. I'm going to plug in 11 to this equation and see if we got it right. Negative 2 times 11 is negative 22. Negative 22 plus 12 is negative 10. I know I did that one correctly. All right, let's move on to letter E. Letter E is one that has a lot of fractions in it. 1/8 m plus 3/4 equals 7/12. Now, one thing that I can do with a problem like this is simply multiply by the least common denominator. If I multiply the whole equation by the least common denominator, it'll get rid of all of my fractions, and that would make things really simple. I could also, if I wanted to, find a common denominator. I could just use the common denominator, and then all of my addition and subtractions will work because I'm adding and subtracting things with a common denominator. So there's multiple ways to do this. I'm just going to multiply everything by the least common denominator. What is the least common denominator of 8, 4, and 12? Well, I could find the least common multiple. We know how to do that. And I know that 4 and 12, well, 12 is the least common denominator of 3/4 and 7/12. But not 8. 8 doesn't go into 12. So I need to multiply this by 2 and make this 24. 8 goes into 24. 4 goes into 24. 24 is my least common denominator. So I'm going to multiply everything in this equation by 24 when I write it out. So it's going to be 24 over 8 times m plus, let's see, 24 times 3 is 72 over 4, because I multiplied this by 24, equals, 24 times 7. That one I'm going to use a calculator for. So it's going to be 168 over 12. Now let's just simplify these right away, because I should get rid of all my fractions by doing this. So all of these division problems should work out. 24 over 8 is just 3. So this is going to be 3m plus 72 over 4 equals, and then 168 over 12. I have no idea what that one is. Okay, now I have an equation in a form that we've seen before, and it's easy to solve. So this is going to be 3m. Let's see. I'm going to subtract 18 from both sides of this. It gives me 3m equals negative 4. And then if I divide both sides by 3, or divide both sides here by 3, my answer is going to be m equals negative 4/3. Notice that starting with letter F, there's something different. I have variables on both sides of this one. What's the first step that I do when I have variables on both sides? I do an inverse operation that gets the variables on one side. So this is 6x equals 3x plus 27. I'm going to subtract 3x from both sides of this equation. Okay, and that gives me 3x equals, now the 3x on this side is going to cancel. 6x minus 3x is 3x, so it's going to be 3x equals 27. Now I'm going to divide both sides by 3, and I think you're going to see the answer. This one's pretty easy. X equals 9. Now to check this one, I could plug in 9 here and 9 here. 6 times 9 is 54. 3 times 9 is 27. 27 plus 27 is 54. X equals 9 works. Let's do letter G. Letter G is 2 plus 3 times 3x minus 6 equals 5 times x minus 3 plus 15. The good thing about this one is it really gives us some practice with that reverse order of operations. What operation do I need to do first? I need to get the x's on the same side, but I need to actually undo addition and subtraction first. How am I going to do that? Well, I'm going to subtract one of these two values from both sides, and the easier one for me to do is the smaller one. So I'm just going to subtract 2 from both sides of this equation to start off. That'll get the extra constant off of this side. So I'll be left with 3 times 3x minus 6 equals 5 times x minus 3 plus 13. Now, there's multiple ways you could do this. I'd say that the simplest way to do this is actually if you have a distributive property problem within these problems, just do the distribution. So it's going to be, if I distribute this 3 to the 3x minus 6, it's going to be 9x minus 18 equals, I'm going to distribute here, 5x minus 15 plus 13. Now I'm going to simplify. 9x minus 18 equals 5x minus 15 plus 13 is just minus 2. And now this looks like a really easy problem to solve. The next step that I'm going to do is I'm going to subtract 5x from both sides. Okay, I could do the same thing to both sides. Let's subtract 5x. That's going to be 4x minus 18 equals negative 2. Now I'm going to add 18 to both sides. So plus 18 on this side, plus 18 on this side. That's going to give me 4x equals 16. And now you see how easy this is. Divide by 4 on both sides. And I get x equals 4. So this whole messy expression, when I apply methodically reverse order of operations, and then I do inverse operations one at a time, doesn't even really matter if you do things at the same in the same order I did them. I did a subtraction step first to get one of these constants over to a side by itself. I could have distributed first if I wanted to. It doesn't really matter. As long as you do this in an orderly way and you keep the rules of algebra, you get the right answer at the end. In letter H, we have 2x plus 3 equals 2x plus 2 minus 4x. Okay, so first thing we're going to do is distribute. 2x plus 2 times x plus 3 equals 2x plus 6 equals 3 times 2x plus 2 becomes 6x plus 6. And then we have that minus 4x at the end. I can simplify this by combining like terms. 6x combines with minus 4x. So this becomes 2x plus 6 equals 2x plus 6. Uh-oh. Whenever you have the same expression on both sides, there's a special answer to the question. I'm going to subtract 2x from both sides first to get the variable off of one side. But wait a second, when I get the variable off of one side, I actually get the variable off of both sides. And I end up with the expression 6 equals 6, which we know is true. The answer to this we call an identity. And whenever we get an identity, it means that all real numbers are a solution to this equation. I could plug in anything I want for x and this equation will be true. Okay, so if you ever end up with a number equals itself, that's a special kind of answer called an identity. Now let's see what happens in the next one. I'm just going to do the distribution step right away to solve time. This is going to be 3x plus 12. Notice I distributed the 3 equals 2x plus 10 plus x. Or when I combine like terms on both sides, I get 3x plus 12 equals 3x plus 10. You may realize that there's a problem here. What if I subtract 3x from both sides to get the x term on a side by itself as we've been doing? Okay, subtract 3x from both sides, I get 12 equals 10. Well, that is not an identity because it's not numbers that are equal. If I ever get a number is equal to a number that it's obviously not equal to, 12 is not 10, the answer is no solution. There is no value of x that will make this true because this equation thinks that 12 equals 10, which is not correct. So the answer to this one is no solution. And that is how you solve equations, especially multi-step equations.